Welcome to Unit 9, Lesson 2. Today's lesson is going to focus primarily on the greatest common factor, or GCF for short. Today's goal specifically is just to be able to find the GCF from a set of numbers and variables. So again, the greatest common factor, or GCF, is going to be the largest number that evenly divides into a set of numbers or expressions, because we are going to throw some variables into the mix as well. So when you're working with variables, the greatest common factor, the biggest amount that you're going to be able to divide out of everything, is always going to be the factor with the smallest exponent. So when we put this to some examples, this is going to make more sense. So you want the biggest number that divides the numbers and the smallest exponent on the variables. Okay, so for now we're focusing on numbers only. So to find the greatest common factor for each set of numbers, if I look at example 1 here with 33 and 22, I want to think of what the factors of those numbers are. So what numbers evenly divide those? Well, I know 33 can be broken down into, it can be divided by 3, it can be divided by 11. When I look at 22, it can be divided by 2, it can also be divided by 11. 11 is my GCF. That's the biggest number that's going to divide both of these. Now, when we look at example 2, I have 7 and 33. Both of these are prime numbers, which means 7 is only divisible by itself in 1. 33 is only divisible by itself in 1. So when it seems like there is not a common factor, you can always divide anything by 1. So in this unique case, our GCF is 1. There's no other number bigger than 1 that's going to evenly divide both of those. Looking at example 3, I have 30 and 40. Since they're both even, I know they can both divide by 2. Since they both end in 0, I know they can both divide by 5. And again, because they both end in 0, they can also be divided by 10. So you want to make sure you're going with the greatest, the biggest common factor. So the biggest number that's going to divide both 30 and 40 is 10. Okay, example 4, same thing. I have 3 numbers, though, that I need to make sure my factor applies to. So I have 32, 48, and 16. So again, I know all of these can be divisible by 2 because they're even. I want to check for anything bigger. I know that I can also divide all 3 of those by 4, make sure there's nothing bigger. And in fact, all 3 of these numbers can be divided evenly by 16. So if you're ever unsure, you can use a calculator, you can check. But the GCF, the biggest number that evenly divides all 3 of those, is 16. Okay, so now when we look at the GCF for variable expressions, okay, remember when we're dealing with variables, we're always going to factor out the smallest exponent. So when I look at example 5 here, I have x and x cubed. Well, x is really just x to the first. So I have 1x being multiplied here, 3x is being multiplied here. So if I want to take something out of both of them, the highest I can go is just going to be a regular x. I can't take more than 1 away from this guy. All right, number 6, when I look at a to the 5th and a to the 8th, the GCF is going to be the smallest exponent I have, which in this case is a to the 5th. So the GCF of those two terms is a to the 5th. That's the most I can divide out of both of those pieces. In number 7, notice I have 2 variables in the mix. I have x's and y's. Still repeats the same process, so focusing just on the x's. I have an x squared and an x cubed. So the smallest exponent is going to be an x squared. When I look at the y's, I have a regular y to the first and a y squared. The smallest of the y's is just y. So my GCF is x squared y. Number 8, same thing. I have a's and b's. Of my a's, a to the 7th and a to the 3rd. A to the 3rd is smaller. Of my b's, b to the 10th and b to the 6th. B to the 6th is smaller. So a to the 3rd, b to the 6th is my GCF for those sets of variables. Now, when we have mixed expressions with both numbers and variables, it's the exact same process that we just did. We're just combining them together. So when I look at number 9, starting with the numbers, I have 25 and 5. The biggest number that's going to divide both of those evenly is 5. And when I look at my variables, x to the 4th and x to the 6th, the smallest exponent is 4. So numbers gave me 5 and variables gave me x to the 4th. So my GCF is 5x to the 4th. Number 10, I want to check my numbers first, 32 and 48. So you might need to do some checking on your calculator, but the biggest number that divides both of those is 16. When I look at the a's, the smallest exponent is 2, so I'm going to have an a squared. And when I look at the b's, the smallest exponent is just b to the 1st, so I'm going to have 16 a squared b. Number 11, 8x to the 4th y and 56x squared. To find the GCF of those, I start with the numbers 8 and 56. The biggest number that will divide both of those is an 8. The lowest exponent on my x terms that they have in common is going to be x squared. And notice I only have a y on one term. I don't have it here, so I can't actually factor out a y. So my GCF is going to be 8x squared. Number 12, now I have 3 terms I need to take into account. Still the same thing. What's the biggest number that's going to evenly divide 6, negative 12, and 6? That answer is 6. And then when I check my variables, x to the 5th, x to the 3rd, and x squared, the smallest exponent is x squared. So my GCF is 6x squared. Okay, so you have 4 problems to try on your own, just focusing on numbers, and then 4 to try on your own with a mix of variables. So go ahead and complete those on your slide assignment. Make sure you submit those to me, and please feel free to email, call, or text if you have any questions.